Hey there, AP Environmental Science class. Today we're going to move on to Chapter 3, Ecosystems. What are they and how do they work? All right, so we're going to get right to it now. The chapter starts off with a core case study talking about how tropical rainforests are disappearing. And tropical rainforests are very, very important to the biodiversity on this planet. Tropical rainforests mainly are near the Earth's equator. They only cover about 2% of Earth's land. However, they contain up to 50% of the world's known terrestrial plant and animal species. So think about that. You have these tropical rainforests. There's not a lot of them, right? They only cover about 2% of the Earth's land, but 50% of the known terrestrial biodiversity lives in that 2% of Earth's land that are these tropical rainforests. So when you get rid of tropical rainforests, you reduce the biodiversity greatly. And that is the big major harmful effect. You also accelerate climate change. You also change regional weather patterns. But really, the main effect is it reduces biodiversity. Because again, 2% of Earth's land equals 50% of the terrestrial biodiversity. So when you start getting rid of that 2% of land, again, you greatly reduce the biodiversity on this planet. And that's a big issue. Natural capital degradation. Here it is. All right. Here's a tropical rainforest about 40 years ago. Fast forward to 2003. Here is that same tropical rainforest. Now, look, we're not talking about high-rise apartment buildings here. We're not talking about roads crisscrossing this area. We're talking about farmland, right? Patches of farmland. So while it is still agriculture being done, it doesn't matter. Even though you have farmland, you greatly reduce the biodiversity. And again, that causes the natural capital to degrade. And once again, we'll talk much more about this as we go through the course, especially when we get to the land use chapter in just a couple of weeks. So how does the Earth's life support system work? Basically, there are four major components of Earth's life support system: the atmosphere, which is the air we breathe; the hydrosphere, which is the water; the geosphere, which are rocks, minerals, and soil; and the biosphere, which basically encompasses all living things. So what we'll do now is we'll talk about each of these components in a bit more detail. The atmosphere, the innermost layer of the atmosphere is known as the troposphere. So if you remember back to Earth science, you have the troposphere, the stratosphere, the mesosphere, and then the thermosphere. We're mainly going to be concerned with the troposphere and the stratosphere. The troposphere, because that's the sphere that we're in right here on the surface. So this is the sphere that deals with the respiration and all the things that we need to keep life going on this planet. The stratosphere is also very important because it contains the ozone layer, and ozone filters out the sun's harmful ultraviolet or UV radiation. I would argue if we didn't have an ozone layer in the stratosphere, there would be no life on this planet. Cells do not like ultraviolet radiation. It kills cells. And so if you didn't have that ozone layer protecting us, the planet would be bleached and there would be no life on the planet. So very important, that ozone layer in the stratosphere. The hydrosphere, all water vapor, liquid water, and ice is considered the hydrosphere. But something I want to point out, the oceans contain 97% of the planet's water. What is ocean water, right? It's salty. We can't use salt water. We can't use it to drink. We can't use it to irrigate our crops. So only 3% of the water on this planet is actually usable for life. Because again, that other 97%, obviously it's usable for sea creatures and plants that live in the ocean. But for us humans, okay, and the things that we hold dear, only 3% of the water here on the planet is usable, and we'll talk more about this when we get to that water use chapter in just a couple of weeks. The geosphere is the upper portion of the crust that contains the nutrients organisms need to live, grow, and reproduce. Okay, the soil, it also contains our non-renewable fossil fuels, all contained in that geosphere. And then the biosphere kind of is the umbrella that encompasses it all. It's parts of the atmosphere, hydrosphere, and geosphere where life is found. So this is just kind of a visual of what I just talked about. There's your hydrosphere, the water; the atmosphere, the air; the geosphere, the crust, mantle, and the core. And then if you kind of break out that a little bit more, you'll notice the biosphere, the atmosphere to some parts of the soil where we have living things. Obviously below that part of the soil where it's just rock, where nothing is living, isn't considered the biosphere. But the biosphere anywhere from, again, some soil that has organisms in it, all the way up through the atmosphere. All right, so let's talk about three factors that sustain life here on Earth. First is the sun. One-way flow of high-quality energy from the sun supports plant growth and warms the troposphere. Obviously, if there was no sun, there would be no life on this planet. Number two, cycling of nutrients through parts of the biosphere, and we'll talk about some of that cycling in just a couple of slides. In addition, gravity holds the Earth's atmosphere and enables movement and cycling of chemicals through air, water, soil, and organisms. So these are the three factors that sustain life on Earth. And again, this is just kind of a visual that kind of shows what we just talked about previously in the notes. Here's the solar energy that powers the Earth climate system, shortwave radiation. Roughly half of it is absorbed by the Earth's surface. Some of it is reflected back into the atmosphere and back out to space. When the Earth does heat up, it releases its heat as long-wave radiation. Okay, many of that is released out into space, but a lot of it is captured by clouds and greenhouse gases in the atmosphere, and then that heat is then, instead of heading out into space, kind of reverses 180-degree turn and then heads back down to the surface of the Earth. So we actually, we'll talk about this more when we get the climate change towards the end of the course, but the greenhouse effect is actually a good effect. Without greenhouse gases in our atmosphere, the average temperature on planet Earth would be about 0 degrees Celsius, meaning there would be absolutely no life on Earth. We need a greenhouse effect. Greenhouse effect is good. We want some of that long wave radiation heading back down to the Earth to keep us nice and warm like a greenhouse. But unfortunately, what we're doing is producing a runaway greenhouse effect by adding more of these greenhouse gases into the atmosphere, and that's causing this greenhouse effect. Actually, I call it a greenhouse effect on steroids, right? It's just increasing and increasing, and that's why our temperatures are slowly rising here on planet Earth. And again, much more of this to come later on in the course. All right, what are the major components of an ecosystem? So ecologists study 5 levels of matter: the biosphere, ecosystems, communities, populations, and organisms. We're going to talk about feeding levels. This is a trophic level. Organisms are classified as either producers or consumers based on source of their nutrients. Producers, also called autotrophs, make needed nutrients from their environment. So again, they produce nutrients, okay? And again, you can think of that word autotrophs. I think of autobiography, right? A biography about yourself. You're making the nutrients yourself that you need to live. And those are what producers are. So here are the major components of an ecosystem. I'm actually going to start from the bottom. There's your atom, right? Goes to the molecule, goes to a cell. Cell then, a combination of cells creates an organism, which is an individual living being. That organism is then part of a population. That population is then part of a community of different populations of different organisms. That community is then part of an ecosystem, which is basically everything living and non-living interacting together. And then, of course, you have the overriding umbrella, which is the biosphere, which is every part of the Earth where life is found. Okay, so those are your major components of an ecosystem. And again, here's just another picture kind of showing this. You have precipitation, okay? You have sun coming in, all right? Producers pull in that carbon dioxide, okay? They release oxygen, they make nutrients. Then we have the primary consumers, like a rabbit that'll eat, okay? The grass will eat the leaves, okay? And then you have the secondary consumer, which is the fox, which is going to eat the rabbit, okay? And then you have organisms that are decomposers, that actually take dead matter, dead organic matter, dead living things that aren't living anymore, obviously, and decompose them into nutrients that are then used by the producers to produce their food with the sun, that then the primary consumers eat, the secondary consumers eat, et cetera, et cetera, et cetera. And this is how that ecosystem stays alive. All right, so ecosystems have several important components. During photosynthesis, plants generate energy and emit oxygen, right? Carbon dioxide plus water plus sunlight equals glucose and oxygen. The oxygen is released. The glucose is stored, okay? There's your energy. Consumers, or heterotrophs, okay, who don't make their own energy, cannot produce the nutrients they need. So they need to get their nutrients somewhere else. Primary consumers are your herbivores, which eat plants. Carnivores feed on flesh and other animals. They're going to be your secondary and your tertiary consumers. And then, of course, we have omnivores that eat both plants and animals. Us humans are in that omnivore characteristic, but we are also most likely considered tertiary consumers, however, because we are at the top of the food chain. All right, so again, here's just a picture. What do we have here? We have a zebra, which would be considered a primary consumer, right? The zebra eats the grass, okay, that are the producers, okay? And then here we have the lion, which probably would be more of a tertiary or the secondary or a tertiary consumer eating that zebra. All right, so we also have decomposers, which are very important, okay? So we got producers, we have consumers, and we have decomposers. Decomposers are consumers, okay, but they release nutrients from waste or remains of plants or animals. Those nutrients are then returned to the soil, to the water, or to the air for reuse. And some of your main decomposers are bacteria, fungi, and detrivores, okay, are also considered your decomposers. All right, so again, here we have a complex system here. You have these, they're vultures, okay, and they're actually considered detritivores, okay, because they are going to eat dead animals and then return those nutrients to the soil in their waste, so that then the producers, the grasses, can grow again to have the stuff there that the consumers will eat. So again, it's all this nice cycle that keeps things going. So here is actually talking about the decomposers. All right, here's your time progression, meaning the left side is when the tree has just fallen down. The right side would be sometime later. So you'll notice your longhorn beetles come in, they start breaking stuff up, right? Carpenter ants come in, start decomposing that wood, right? Then you have this fungus comes in, continues to decompose the wood, and then eventually these mushrooms come in, the fungi, which are the decomposers, powder broken down by decomposers, then return to the soil as plant nutrients, and then the whole cycle will start again. So these are how ecosystems work. Again, producers, consumers, and decomposers use chemical energy stored in glucose. In most cells, energy is released by aerobic respiration, right? Using oxygen to turn glucose back to carbon dioxide and water. That's what we are doing, okay? So here again is your cycle: solar energy, producer plants. Here's your consumers, okay? Well, let me go back to that. Sorry, guys, consumers. Here are your decomposers. There it then goes to the chemical nutrients, okay, back into the soil, back into the air, and then the whole cycle starts again. What I do want to point out is you notice this, every offshoot of a cycle has this heat, okay? That is that waste we talked about in the previous chapter, okay? We talked about how energy, every time it goes through levels, actually decreases. The energy, the quality of the energy decreases. And this is why, because the energy is going to be released in most cases as heat, and that then degrades or reduces the energy quality just a bit. So again, that solar energy coming in does get reduced as we go through this cycle, okay, of this ecosystem cycle. So just something to keep in the back of your mind. All right, soil is the foundation of life on land. Soil is a complex mixture of rock, particles, mineral nutrients, organic matter, water, air, and living organisms. Soil is a renewable resource, but it is renewed very, very slowly. So for instance, I have a mulch pile in my backyard. All right, I throw my leaves back there. I throw any organic waste back there. Takes about a year and a half, but if I dig down deep, I have great soil, and then I actually use that soil in my garden. But it takes about a year or two to actually get that soil to be renewed. All right, so that's going to be it for part one. All right, what happens to energy in an ecosystem? I will start off with part two with this slide. So I will see you then.